The National Electrical Code, or NEC, mandates specific requirements for electrical installations in detached garages. In your situation, where you're planning to install a 60-amp panel in a detached garage fed from a 240/120-volt single-phase panel with a 200-amp main breaker in the basement, it's crucial to understand these requirements to ensure safety and compliance. The core issue revolves around whether the garage subpanel can be a main lug panel or if it needs a main breaker. According to the NEC, a main lug panel is permissible only if it's located within sight of the main service disconnecting means. Since the garage is detached from the house, it inherently isn't within sight of the main service disconnect, which is located in the basement panel. This lack of direct visibility triggers the NEC requirement for a separate service disconnecting means at the detached structure, in this case, the garage. What this means in practical terms is that the panel in the garage must incorporate a main circuit breaker or a fusible switch. The purpose of this requirement is to provide a readily accessible means of disconnecting power to the garage in case of emergencies or for maintenance purposes. This local disconnect ensures that anyone working in the garage can quickly and safely energize the electrical system without having to run back to the main service panel in the house. Now, let's talk about sizing the main circuit breaker or fusible switch in the garage panel. The NEC stipulates that this disconnecting means must be sized to protect the conductors that supply the garage. To determine the appropriate size, you need to consider the ampacity of the conductors feeding the garage panel. Ampacity refers to the current carrying capacity of a conductor, and it's determined by factors such as the conductor's material, size, insulation type, and installation method. You mentioned that the conductors supplying the garage are rated for 100 amps. Therefore, the main circuit breaker or fusible switch in the garage panel must be rated at 100 amps or less. It's important to note that you can use a breaker smaller than the ampacity of the conductors feeding it. For instance, you could use a 60-amp main breaker if you choose. Using a breaker larger than the ampacity rating of the wires that feed it would create a hazardous situation. This is because if the demand increased to, say, 80 amps, the wire could overheat, melt the insulation, and cause a fire while the breaker remains on. This is why it is important to choose a breaker that is appropriately sized to the wire gauge feeding it. To clarify further, let's delve a little deeper into the specifics of panel types. A main lug only, or MLO, panel is designed to receive power from an upstream overcurrent protection device such as a circuit breaker or a set of fuses. These panels lack a built-in main breaker and are typically used as subpanels in situations where the main overcurrent protection is provided elsewhere. On the other hand, a main breaker panel incorporates a main circuit breaker that serves as the primary disconnecting means and overcurrent protection for the entire panel. This type of panel is commonly used as the service entrance panel in a building or as a subpanel in situations where a local disconnecting means is required, such as in a detached garage. It is critical to note that the NEC does not allow you to simply install a breaker ahead of an MLO panel in situations where a main breaker is required. So, to summarize the key takeaways, firstly, the NEC mandates that a detached garage must have a separate service disconnecting means. Secondly, this disconnecting means must be a main circuit breaker or fusible switch located within the garage. Thirdly, the size of the main circuit breaker or fusible switch must be appropriate to protect the conductors supplying the garage. Therefore, in your specific case, the panel in the garage must have a main circuit breaker or fusible switch, and it must be sized appropriately to protect the conductors feeding the garage. Let's expand on the specific sections of the NEC that address these requirements. While I cannot provide exact section numbers without knowing the specific edition of the NEC being used in your jurisdiction, I can point you to the relevant articles and sections that cover these topics. Generally, the requirements for service disconnecting means are covered in Article 230 of the NEC, which deals with services. Within Article 230, look for sections that address the location and rating of disconnecting means. These sections will specify the requirements for having a readily accessible disconnecting means at each building or structure, including detached garages. Additionally, Article 225 of the NEC, which covers outside branch circuits and feeders, may also contain relevant information regarding the requirements for supplying power to detached structures. Furthermore, Article 408, which pertains to switchboards and panel boards, provides requirements for the installation and overcurrent protection of panel boards. Within Article 408, you'll find sections that address the use of main breakers and the proper sizing of overcurrent protection devices. To ensure compliance with the NEC, it's essential to consult the specific edition of the code that is adopted in your jurisdiction and to carefully review the relevant articles and sections mentioned above. Keep in mind that the NEC is a comprehensive document, and it's always a good idea to consult with a qualified electrical inspector or a licensed electrician to ensure that your electrical installation meets all applicable requirements. Now let's delve into some additional considerations related to the electrical installation in your detached garage. Firstly, grounding and bonding are critical aspects of electrical safety. The NEC requires that all electrical equipment in the garage, including the panel board, be properly grounded and bonded to ensure a low impedance path for fault current to return to the source. This grounding and bonding system helps to protect against electric shock hazards and to facilitate the operation of overcurrent protection devices in the event of a fault. Secondly, wiring methods play a significant role in ensuring the safety and reliability of the electrical system. The NEC specifies various wiring methods that are permitted for use in different types of locations and environments. In a garage, it's important to choose wiring methods that are suitable for the environment, taking into account factors such as moisture, temperature, and potential physical damage. Common wiring methods used in garages include rigid metal conduit, electrical metallic tubing, and non-metallic sheath cable, commonly known as Romex. Thirdly, lighting is an essential aspect of any garage electrical system. The NEC provides requirements for the type and placement of lighting fixtures in garages to ensure adequate illumination and safety. Consider using energy-efficient LED lighting fixtures, which provide bright and long-lasting illumination while consuming minimal energy. Fourthly, receptacle outlets are necessary for powering various tools and equipment in the garage. The NEC specifies the number and location of receptacle outlets required in garages, as well as the types of receptacles that are permitted. Be sure to install ground fault circuit interrupter, or GFCI, protective receptacles in areas where moisture is present, such as near workbenches or sinks, to protect against electric shock hazards. Fifthly, surge protection is an important consideration for protecting sensitive electronic equipment in the garage from voltage surges caused by lightning or other electrical disturbances. Consider installing a surge protective device, or SPD, at the main panel board in the garage to divert surge current away from electronic equipment. It is critical to not overload circuits. Given that you are planning to have 1-30 amp circuit, 2-20 amp circuits, and 2-15 amp circuits, you need to perform a load calculation to ensure that the 60 amp panel in the garage can handle the anticipated load. Add up the amperage of all the circuits. In this case, 30 amps plus 2 times 20 amps plus 2 times 15 amps totals 100 amps. This appears to be greater than the 60 amp service. However, it is unlikely that every circuit will draw the maximum amperage at the same time. Nonetheless, if the likelihood is high that the loads will be at or near maximum, you should consider a larger panel or make adjustments to the loads placed on the panel. The NEC provides guidelines for performing load calculations to determine the appropriate size of service and feeder conductors and overcurrent protection devices. These calculations take into account factors such as the square footage of the garage, the types of appliances and equipment that will be used, and the anticipated usage patterns. By performing a load calculation, you can ensure that the electrical system is adequately sized to handle the expected load without overloading the circuits. Now, let's briefly discuss the process of obtaining electrical permits and inspections. Before starting any electrical work, it's essential to obtain the necessary electrical permits from your local building department. The permit application will typically require you to submit plans and specifications for the electrical installation, as well as information about the licensed electrician who will be performing the work. Once the electrical work is completed, you'll need to schedule an inspection with the local building department to ensure that the installation complies with the NEC and other applicable codes and regulations. The electrical inspector will examine the wiring, grounding, overcurrent protection, and other aspects of the electrical system to ensure that it meets all safety requirements. If the installation passes inspection, the inspector will issue a certificate of approval, which is required to energize the electrical system and put it into service. In summary, the electrical installation in your detached garage must comply with the NEC and other applicable codes and regulations. This includes having a main circuit breaker or fusible switch in the garage panel, properly sizing the overcurrent protection devices, ensuring proper grounding and bonding, using appropriate wiring methods, providing adequate lighting and receptacle outlets, and protecting against voltage surges. By following these guidelines and obtaining the necessary permits and inspections, you can ensure that the electrical system in your detached garage is safe, reliable, and code compliant. Now let's take a moment to address some common misconceptions about electrical installations in detached garages. One common misconception is that a main lug panel is always acceptable in a detached garage if it's fed from a circuit breaker in the main panel. While it's true that a circuit breaker in the main panel provides overcurrent protection for the feeder conductors, it doesn't satisfy the NEC requirement for separate service disconnecting means at the detached structure. The disconnecting means must be located within the garage itself for easy access and safety. Another misconception is that the size of the main circuit breaker in the garage panel must always match the ampacity of the feeder conductors. While it's important to protect the feeder conductors from overcurrent, the main circuit breaker in the garage panel can be sized smaller than the ampacity of the conductors, as long as it's large enough to handle the anticipated load in the garage. A third misconception is that GFCI protection is only required for receptacle outlets located near water sources in the garage. While it's true that GFCI protection is essential in damp or wet locations, the NEC also requires GFCI protection for all 125-volt, 15A and 20A receptacles in garages, regardless of their proximity to water. This is because garages are considered to be potentially hazardous environments due to the presence of tools, equipment, and vehicles that can increase the risk of electric shock. By understanding these common misconceptions and adhering to the NEC requirements, you can ensure that the electrical installation in your detached garage is safe, reliable, and code compliant. Finally, let's discuss the importance of hiring a qualified electrician for any electrical work in your detached garage. Electrical work can be dangerous and should only be performed by individuals who have the necessary training, experience, and qualifications. A qualified electrician will be familiar with the NEC and other applicable codes and regulations, and they will have the tools and equipment needed to perform the work safely and correctly. They will also be able to assess the electrical load requirements of your garage, recommend the appropriate size of panel board and overcurrent protection devices, and ensure that the electrical system is properly grounded and bonded. Hiring a qualified electrician may cost more upfront, but it can save you money in the long run by preventing costly mistakes, avoiding safety hazards, and ensuring that the electrical system is installed to code. Moreover, a qualified electrician will be able to obtain the necessary electrical permits and schedule inspections with the local building department, which can save you time and hassle. In conclusion, the electrical installation in your detached garage must comply with the NEC and other applicable codes and regulations. This includes having a main circuit breaker or fusible switch in the garage panel, properly sizing the overcurrent protection devices, ensuring proper grounding and bonding, using appropriate wiring methods, providing adequate lighting and receptacle outlets, and protecting against voltage surges. By following these guidelines, avoiding common misconceptions, and hiring a qualified electrician, you can ensure that the electrical system in your detached garage is safe, reliable, and code compliant. Remember to always consult the latest edition of the NEC and to check with your local building department for any specific requirements or interpretations that may apply in your jurisdiction.